Welcome to Daily Papers, the podcast where we break down one interesting research paper every day, so you don't have to.
Today's big question: could an AI do your job? Okay, maybe not your job specifically, but what if your job was scientific researcher? I mean, could an AI come up with a research idea, find the data, do the analysis, and write a publishable paper all on its own?
It sounds like science fiction, but it's a question researchers are taking very seriously. And today's paper introduces an AI assistant designed to do just that. It's called NORA, which stands for Night Owl Research Agent. And NORA isn't just any AI, it's a specialist.
Right, because that's the first hurdle. Most AIs we hear about are generalists. They can write a poem, then a marketing email, then some computer code. But science is incredibly specialized. An AI that's great at writing song lyrics probably doesn't know the first thing about the correct statistical methods for mapping earthquake aftershocks.
Exactly. And the field NORA specializes in is called Spatial Data Science. This is a perfect example of a field where you can't just be a generalist.
Let's break that down. What is spatial data science?
In the simplest terms, it's data science with maps. The spatial part means location is key. We're not just looking at what happened, but where it happened. Think about tracking the spread of a disease, analyzing crime hotspots in a city, or figuring out the best place to build a new wind farm. The where is everything.
And not where makes things complicated. If you're studying the link between air pollution and health, you can't just throw all the data into a spreadsheet and hit go. A measurement from a downtown street corner is fundamentally different from one in a suburban park. The relationships between things change across space.
Precisely. Generalist AIs often miss this. They might use a standard statistical model that assumes all data points are independent, completely ignoring the fact that houses in the same neighborhood probably share a lot of characteristics. It's a rookie mistake that a human expert would never make.
So the researchers behind this paper saw this gap. They realized that to automate research in a field like this, you need an AI that thinks like a geographer. And that's NORA.
And NORA's design is really the clever part. It's not one single giant AI brain. It's designed as a multi-agent system. Think of it like a research team made up of 9 different specialist AIs.
Oh, that's cool. So you have a little AI team.
Yep. There's a literature scout agent that goes out and reads all the existing research. There's a geospecialist agent that's the expert on map data and spatial statistics. There's a hypothesis generator, a paper writer, and even a peer reviewer agent whose only job is to critique the work of the other agents.
A peer reviewer. That's brilliant. We'll come back to that. So it's a team of specialists, and I'm guessing they have specific tools to work with.
They do. The system is built on what the paper calls a skills-first architecture. NORA has 21 domain-specialized skills. These aren't just vague abilities. They're like detailed instruction manuals or decision-making flowcharts for specific tasks.
So instead of the AI just trying to figure out how to download climate data from scratch, it has a skill that tells it, go to these trusted government sources, get the data in this format, and make sure you document exactly where you got it for reproducibility.
You've got it. It embeds the best practices of the field directly into the AI's workflow. This makes the research much more rigorous and trustworthy than what a general-purpose AI might produce.
But even with a team of specialist AIs and detailed skills, you still have the problem of, well, letting an autonomous program run your research. What if it gets stuck or goes off on a weird tangent or accidentally tries to delete your hard drive?
This is my favorite part of the paper. They tackle this with a concept they call harness engineering. The idea is that the AI agent itself is just one part of the system. The harness is all the scaffolding and safety features built around it to keep it reliable, controllable, and robust.
It's like putting safety rails on the AI highway.
A perfect analogy. For example, the harness includes a human-in-the-loop system. NORA is programmed to know when it's out of its depth. It will literally pause its work and ask for human input. It might say, I've generated 3 possible research questions. Which one do you think is the most promising? Or, I need to download a 50-gigabyte dataset to continue. Do you authorize this?
So it's not a black box that you just press go on and hope for the best. It's more of a collaborator.
Exactly. And remember that AI peer reviewer we mentioned? That's part of the harness too. It's a principle called generator-evaluator separation. The AI agent that writes the paper, the generator, is not allowed to evaluate its own work.
Because that would be like a student grading their own homework. They'd always give themselves an A+.
Right. So NORA calls in a separate, colder evaluator agent that has no access to the writer's reasoning. Its only job is to critique the finished text, just like a real academic peer reviewer would. This prevents the AI from getting stuck in a loop, getting overconfident, and falling in love with its own bad ideas.
Okay, so the design is incredibly thoughtful. You have a team of specialist AIs with expert skills and a safety harness to keep them on track. The million-dollar question, does it actually work?
It does, surprisingly well. The researchers gave NORA 3 real-world case studies. They gave it a brief, and NORA had to do the entire research lifecycle: literature review, data collection, analysis, and writing a publishable paper, all on its own.
And what was the verdict?
Human domain experts and other AIs were asked to review NORA's work. The consensus was that it can produce research of moderate to strong scholarly quality. The computer code it generated was rated especially highly. It was clean, efficient, and well documented.
But not perfect, I'm guessing. Where did it fall short?
The main weakness was in a quality the paper calls rigor. This is the subtle, nuanced part of science, the careful interpretation of results, acknowledging limitations, and understanding the deeper context. That's where the human touch is still essential. In fact, the human reviewers gave NORA's papers lower scores than the other AI reviewers did.
That's hilarious. The humans were the toughest critics.
It shows that while an AI can follow the steps and assemble the pieces, that deep critical thinking is still a human skill. The paper doesn't position NORA as a replacement for scientists, but as a massive research accelerator.
It handles all the tedious and time-consuming parts, finding and cleaning data, writing boilerplate code, formatting citations, which frees up the human researcher to focus on the big, creative, important questions.
So, NORA is this incredible blueprint for how to build specialized, trustworthy AI for science. It shows that the future isn't just about making bigger language models, but about building these careful, clever harnesses around them.
It's a powerful research assistant that knows its own limits and knows when to ask for help from its human boss, which honestly is more than you can say for some human assistants.
That's all the time we have for today. Thanks for tuning in to Daily Papers.